Rational exponents. A rational exponent is an exponent that is a fraction. Let's recall some things about exponents. If we have 4 to the second power, we know that that means 4 times itself, or 4 times 4, which would be 16. If we have 4 to the negative 2 power, the way that we get rid of a negative exponent is to take the reciprocal of the base. So this would be the same thing as 1 over 4 squared, and that would give us 1 over 16. Now let's see what we do if we have 4 to the 1/2 power. Well, to know what we do, we need to know the definition. The definition says that a, or any number raised to a 1 over n power, is the same thing as the nth root of a. So that just means that if we have an exponent that is a fraction, the bottom number is the root, the index of our radical. So if you just think about the fact that roots grow on the bottom number is the index of our root. The top number is our power. This says to rewrite each rational exponent as a root. So all we're doing is we're rewriting it as a radical. So like I said, the number that's on the bottom, that's the index of our root. So this would just be the square root of 4. Well, you know, whenever we write the radical, when it's a square root, we don't put a number in the little pocket. So we just write it like this. But for number 2, this is 27 to the 1/3 power. So my index is going to be a 3, so this would be the cube root of 27. Number 3, it's 625 to the 1/4 power. So I would just rewrite this as the 4th root of 625. In these next few problems, we're to find the value of each. So we're not just rewriting it, we also need to simplify and find the value. 64 to the 1/2 power would be the same thing as the square root of 64. Well, now we need to find that value, and the square root of 64 is 8. For number 5, we have in parentheses the negative 64 to the 1/2 power. So that would be the square root of negative 64. But remember, we can't take an even root of a negative number. So this would just be no real root or no real solution. For number 6, 64 to the 1/3 power would be the cube root of 64. Number 7, in parentheses, negative 64 to the 1/3 power would be the cube root of negative 64. Oh, I didn't finish number 6. Well, we need to find the value of the cube root of 64, and the cube root of 64 is 4. For number 7, the cube root of negative 64 would be negative 4. Because remember, we can take an odd root of a negative number. If I multiply negative 4 times negative 4, I get a positive 16, and then positive 16 times negative 4 would give me a negative 64. Number 8 is very similar to number 5. Can you see what the difference is? There's no parentheses in number 8. So this means the negative is not being raised to the power. Only the 64 is being raised to the 1/2 power. So that means only the 64, we're only taking the square root of 64, and that 1/2 stays on the outside. So we can do this since the negative is not under the radical. And this would be -8 because the square root of 64 is 8. For number 9, we're taking 1/8 to the 1/3 power. It's in parentheses, so the whole 1/8 is being raised to the 1/3 power, which is the cube root of 1/8. So we're just taking the cube root of each part. The cube root of 1 is 1, and the cube root of 8 is 2. Now number 10 has 1/8 in parentheses raised to the -1/3 power. Well, remember the way that we get rid of a negative exponent is to take the reciprocal of the base. So if I take the reciprocal of 1/8, I get 8. 8/1, which is 8. That turns that exponent into a positive 1/3. So now it's just 8 to the 1/3 power, which is the cube root of 8. And the cube root of 8 is 2. Alright, again, we're rewriting each rational exponent as a root, but these exponents have numbers other than 1 for the numerator. So if you'll remember, I told you that the bottom number is the root and the top number is the power. So to rewrite a number like this, my root, or the index of my root, is 3. So it's the cube root of 8, but all of that is being raised to the second power. Okay, for number 12, my root, the number that's on the bottom, is 2. So it's the square root of 4, and then my power is 3. Alright, to find the value of each, I'm going to do the same thing. My root is on the bottom, so 16 to the 3/2 power. My root is 2, so it's the square root of 16 raised to the 3rd power. Well, the square root of 16 is 4, and 4 to the 3rd power is 64. (27) to the 2/3 power, my bottom number is 3, so the index of my root is 3. That's a cube root of 27, and it's squared because my power is 2. The cube root of 27 is 3, and 3 squared is 9. For 16 raised to the 3/4 power, the index of my root is 4, and my power is 3. Well, the 4th root, or the number that I can multiply times itself 4 times to get 16, would be 2. And 2 to the 3rd power is 8. (8) in parentheses raised to the 4/3 power would be the cube root of -8 raised to the 4th power. Well, remember, we can take the cube root of a negative number. The cube root of -8 would be -2 to the 4th power. And -2 to the 4th power, -2 times -2 would be +4. +4 times -2 would be -8. And -8 times -2 would be a +16. For number 17, we have a negative exponent, so we need to take the reciprocal of our base, which would be a -1/8. It doesn't change the sign of the base, it only changes the sign of the exponent. So now we have a -1/8 to the positive 4/3 power, and that would give me the cube root of negative 1 over 8 raised to the 4th power. Well, the cube root of negative 1 over 8 would be a negative 1/2, and negative 1/2 raised to the 4th power would become positive 1 over 16. Let's remember what we do when we're multiplying like bases. If we multiply like bases, as in this example here, x squared times x to the 3rd, remember our base stays the same, but we add the exponents. So this would be x to the 5th. Well, it's the same way when we're dealing with rational exponents. If our bases are the same and we're multiplying our bases, we just add the exponents. So this would be x to the 4 over 2 power, because when we're adding fractions, as long as we have a common denominator, we just add the numerators. And then we would need to simplify. Well, 4 over 2 is 2, so it would just be x squared. That's what we do when we're multiplying our bases. When we're dividing our bases, remember we subtract the exponents. So this would be the same thing as x to the 3 minus 1. There's an understood 1 on the x in the denominator. And so we would get x squared. So it's the same way when we're dealing with rational exponents. This would be x to the 3/4 minus 1/4, which would give me x to the 2/4, or x to the 1/2. All right, here we have x to the 2/3 power times x to the 5/3 power. We're multiplying our bases, so we're going to add the exponents, and that gives me x to the 7/3 power. Number 9, again, we're multiplying, and we need to add the exponents, but our exponents don't have the same denominator. So we have to get a common denominator, and the least common denominator would be 4. So that means for that first term, I need to multiply its exponent by 2. And that gives me x to the 2 over 4 power times x to the 3 over 4 power, which is x to the 5 over 4. Again, I'm multiplying like bases. I could actually do 21 in one of two ways. If I were going to multiply my bases and I add the exponents, I'm adding 4/3 plus a negative 1/3, which would give me x to the 4 minus 1 is 3/3, or just x. Or I could get rid of that negative first, and I have x to the 4/3 power times 1 over x to the positive 1/3 power, which would be the same thing as x to the 4/3 over x to the 1/3. And then I just subtract my exponents, which would still be x to the 3/3, which is x to the 1. For number 22, I'm dividing, so I need to subtract. This is x to the 1/3 minus 1 over 6. Again, I need a common denominator. My least common denominator would be 6, so I need to multiply by 2. So that gives me x to the 2 over 6 minus 1 over 6, which is x to the 1 over 6 power.